2, 1. Okay, hello everybody. Welcome to the group training. So my name is Clinton, and let me just move the camera around just to show your faces just quickly for a few seconds. It's James, and Sue, and Richard, and Stephen. Thanks. I'll just introduce myself first. So, yes, I mentioned my name is Clinton, and I work for Altair, and today we are going to do like a group discussion on the software called PBS Professional, which many of you are using or intend to use in the future or have interest in it. So I'm the application engineer for PBS Professional, so I look after local support and all that. And so maybe we'll just go through a round of introduction, and then we'll get to see your work and your background, what you do for your work and so forth. So James, would you like to start?
Background.
Yep.
I started out in biochemistry and ended up in IT. I'm basically a Unix system administrator that looks after Linux now, and we have our HPC in the school, so learning a little bit about a PBS Pro might be useful.
Okay, good. And just to add, James has got a lot of computer network experience over a long time, so he's like the guru of networking. So welcome, James.
Thank you.
And Sue from the School of Physics.
Yes, I'm Center Computational Officer in School of Physics. So mainly I'm supporting software, application software, and the user support.
Okay.
Particularly, I'm supporting the users with their HPC, high performance computing procedure.
Okay.
And other software support as well.
Okay, good. Yeah. So it'll be very sort of beneficial, I think, for you to learn more about PBS Professional and how you can provide the best support for your users. And Richard from the School of Chemistry.
Yeah, and I'm the systems manager. Manage our School of Chemistry, the Silica cluster. And at the moment, we are setting up a new cluster called Quartz. And we intend to use a PBS Pro.
Okay. Okay, that's good. That's very good. And yourself, Stephen?
Yeah, I'm Stephen. My background is in chemistry. I've done a PhD in chemistry here at the School of Chemistry. But I use a lot of HPC in my time, and now I am providing support for researchers who use Sydney University's central HPC cluster, and that's running PBS Pro. So I run training and provide end user support for using this. So
good, thank you. Again, you're the perfect fit to attend this section. Okay, so we'll start by the disclaimer. Let's see. Okay, so I'm just going to read through the video disclaimer. So this session or presentation is being recorded for assessment purposes for my course with Open Colleges. This recording will be live streamed through Open Colleges online learning platform to the Open Colleges learning management system. These sessions may be used by Open Colleges for compliance purposes or within the course to demonstrate examples of best practices. This video may be available publicly supplied to the time the video is being streamed. After the recording, the video will be stored securely and will become the property of Open Colleges. If you do not wish to be recorded, you'll need to leave the session now. Okay, so a few other items like the exits are, this is on the 4th floor, so the exits are through the stairs to downstairs, the meeting point, and the toilets are downstairs as well. And then in terms of occupational health and safety and WHS, so the systems here, the university computer systems here are well tested. They are safe electrically, and there's no wires on the floor to trip anyone. So, okay. All right, just a brief point on the session plan. So we have started with the introduction of everyone. So we've read the disclaimer and the OHS. And then I think I've covered a bit of the individual experience too. But I think as we go through this group session, we'll see more about your individual needs on the use of the HPC and PBS Professional. So we'll bring out more of that individual experience and needs there. And then so as we go through the content, so it'll be quite an interactive discussion. So it's not a presentation or seminar. It's more like a group discussion led by the training content itself. And then we'll have a wrap up. Okay. So the title or what this presentation is about PBS Professional, which is a workload management and scheduling software. So we're going to cover the broad architecture just so that you understand the components of it, because it may help you in debugging for your users. And then we're going to go through the PBS resources. There's built-in resources versus the custom resources, which are resources you can make yourself. And also limiting resources where you can apply limits to your users, groups, and so forth. And then scheduling policies is a very big chapter. There's a big content inside there. We'll go through the important ones and the ones that you like to hear about, and then we'll talk around that. And hooks will be covered in the session 2. So this first 40 minutes will be session 1, and then after a small break, we'll go into session 2 where we will be covering the hooks topic. Okay, so let's start. I'm going to skip through a lot of the marketing slides. I'll just show you. So this one is about where you can get information to help. So typically this, like the commercial PBS Professional, these guides are very useful. The administrator's guide has got everything you need to know for PBS. User's guide is like a cut down version for users. So admin, you don't maybe need to see the user's guide. Reference guide is very good. It's got all the details like tables of some codes or something. Installation guide is a definite read if you want to install your own PBS. And then some programmer's guide for very specialized things that you need to do, like writing your own interface or something to the code. And then there's some release notes for every release. Now these are the different platforms we support. I'll just skip through that in the interest of time. MPI as well. So we support different branches of MPI, but they have to be what we call tightly integrated with PBS. Otherwise, it will not work well. So as an example, OpenMPI is tried and tested. It's open source as well. So that's the recommended one to go for.
Are those versions, does you have to use specifically those versions listed there, or can you use any versions you like, as long as you integrate it correctly?
Yeah, that's right. As long as you follow the instructions to integrate with PBS, you should be able to use your own version.
Just those versions, okay.
Correct. So these are the ones that are supported. So that means that if you have got a question, if something goes wrong, you can ask us. But if you do your own version, then we may not know exactly how you have built it. So we can't really officially say we support it.
Yeah.
But we'll try to help as best as we can. We don't just turn you away. But
okay.
Yeah. So this support, I'll just mention, is the commercial support. So that means when commercial customers, they buy the package, they get 1 year support together with it. So they pay the floating license every year. With the PBS open source, there is also we use the forum for the open source support. So that means the users get to support each other through the forum. And then on top of that, if some customers need, they can buy just the support package from us, because they can download the source easily. So they just buy like the 1 year support from us.
Has the Adams PBS integrated with the NPI?
Oh, absolutely, yeah. We've got a number of versions available.
Well, but this is different. That means PBS itself has NPI.
Yeah, so our MPI can read, I don't know, it's like you need to, it can read PBS node file. And then use that to, send to party jobs at different nodes. So things like, I think it's things like that
Correct. Yes.
Okay.
Yeah.
I'm not aware.
I think you got the point. Yeah. Just to bring another point to it. So the MPIs itself, the different flavors of it, are developed by many different
Yes.
people,
Yes.
universities,
Yes.
government.
Yes.
So, but before it can work well with PBS, PBS needs to be tightly integrated in the sense that it needs to know what the MPI is doing. So MPI is at the bottom level, so PBI needs to know about it. So imagine your job is multiple nodes, right? So when the particular task is finished on a certain node, then PBS needs to know that it has finished. So there's another layer that PBS needs to do to integrate with it. Okay, so there's a whole chapter on how to do this, but for most of the packages, those packages has been done, and also OpenMPI. When you download the OpenMPI source code, and you just configure it with a switch. There's a switch called PBS underscore TM RSH or something. Look up in the document, has got exact details. So once you configure that OpenMPI source code, and then you make install, that means that's all.
Right.
That's
Yeah,
needed.
there's an
That's all.
option
Yeah.
when you install the MPI library. That
Yes.
Which job manager
Yeah.
you need to move to.
I see.
That's the one.
I see.
Okay.
You can do it. Yeah. So with OpenMPI is that one. I'm not too sure about the other MPI.
Right.
So with the others, maybe it is the PBS that needs to tell to know about the MPI. Yeah. But it's there. So the standard ones are well done already. It's like Intel MPI is supported on Artemis, right? And OpenMPI, of course. Yeah. So these ones are for like different platforms, like the SGI has got their own, IBM has got its own special one, and other vendors have got their own MPI, which is very tuned to the system. Yeah. Okay, let's. I'll just skip through until I find relevant or interesting bits. Okay, so the PBS professional is like a server and compute nodes architecture. So you have only one server daemon and one schedule daemon running for the entire cluster, and then you can have as many compute nodes as you want. So on each of the compute nodes, you install what we call the PBS mom daemon there. So maybe if I ask you all to maybe explain from your experience, maybe from Talk or Moab, is it something similar, do you think? Yeah.
Yes, but I noticed that with the PBS Pro, there's another daemon called for communication.
All right, you're right, correct.
So is that the new part that makes the communication between the server and the nodes faster, the communication faster?
Yeah, that's a good point, a good question. The PBS COM daemon was brought in on PBS 13. So before that, PBS version 12 was without the COM daemon. PBS version 12 and below, they use something called the UDP underlying network infrastructure to talk between the server and the mom. But then there's a big change going to 13 because TCP is more modern and it's faster, more robust. So we changed the underlying network architecture to run using TCP as the default. So that means that's where the new daemon was required, the PBS COM daemon. Now for system administration and user purposes, you almost never need to know about the COM daemon. You just need it to install it.
Yeah.
And for even a mid-sized cluster like Artemis, or even beyond Artemis, 2 or 3 times or maybe 10 times beyond Artemis, it may need only one PBS COM, and it will install by default on the PBS head node. It's only for those maybe hundreds of thousands of nodes machine that you may need like maybe 3 or 4 more PBS COM daemons, so that the multiple COM daemons can then share network communication. So James, maybe you have some input on that, of what you think about it.
I presume that you need daemon because unlike UDP, you've got to maintain a connection.
Yeah.
With UDP, you just throw it to the wind and hope for the best.
Yeah.
With TCP, you've got to have a connection.
Yes.
And if you put that all into one server process, it would get bogged down just looking after communications.
Yes,
So
yes.
that's the reason why.
Correct, yeah, that's right. That's right. So they have a separate daemon. So the summary is that usually even sysadmins don't need to bother with it. Unless something goes wrong, then there's some log messages that we can request for it. We investigate.
But I understand that the talk, remember the talk? They don't use this common daemon, but they communicate through TCP.
Yeah, within the SSH process is actually handling the connection. They haven't built in an SSH library into the server then. So yeah, you're offloading to a separate process. Again, is incorporated from that.
Do you know that NCI, what job manager?
They're using PBS 13.
Oh.
So you're talking about Rygen, the Rygen system, right? Yes. Using PBS 13. So
license, the commercial version?
Of course, yes. They have a site license.
Oh, yeah. We have 13.1.
So with big sites like that, they want to pay the license. They even sometimes they request us for commercial version, because by doing that, they can offload the risk and the support to someone else. So if something goes terribly wrong, it needs the code to be fixed underneath. Then with that commercial license, they can tell us they want this to be fixed very soon. These are critical buttons and so on. Or even feature requests, you can ask for feature requests. So that's the reason.
I remember that years ago, NCI, they have their own version.
Correct.
They developed their own version based on
exactly.
So I wonder maybe.
Yeah, exactly.
But
so
now they switch to.
They use their own version up until the year 2013. So when they bought the Fujitsu Ryzen machine, the current one, then they changed to PBS, the commercial one. They came to us. Okay. So the reason is that that risk was realized because that ANU PBS version was developed by a single person. So that person left. So that risk became a reality.
Yes.
So they don't want that to happen again. So that's why they bought a commercial version. And because it was such a specialized PBS branch, so when they came to us, they say that you must have all this, and this.
Yes.
And as part of the agreement, we developed all of that before they, so that they will get our stuff.
Right.
Otherwise, they may have got some other commercial product. So we agreed to develop all those different things that they want to be almost identical to the ANU PBS. Right. Of course, it can never be identical, but the core functionality, the behavior of the schedule is there. And so that was PBS 12, but they have their own branch because they have so many of these features in there. So they're getting their own branch, and then up until when it comes to PBS 13, we merge it back to our thing. So they are running the general PBS 13 version now.
So 13's got a lot of the NCI.
The good stuff from NCI, yes.
Like it with that stuff.
Yeah.
And does the 14 include everything?
Yeah, of course. So 14 builds on that. Yeah. And for 14, the commercial one, built on top of the 14 open source one. So it's taking some of the bug fixes from the open source 14. Yeah. Because 14.2.1 commercial is now released.
Right. But what's the difference between technically commercial version and the open version?
They try to maintain almost the same.
Okay.
Yeah. Being like a slightly separate branch, there's always a lag, right? But they always try to catch up with each other. So think of it as the normal Linux maintained by Linus or someone, and then the Red Hat Linux, Enterprise Linux or whatever. They always try to catch back up to the.
So they are separate development teams.
I think it's the same team, but maybe different source code branches. Yeah. So
the commercial one would be lagging because you don't want to introduce features and break things.
I see.
So like the Red Hat kernels are way behind the general release kernels, but they always backport anything important from the later kernels to keep things going back. They don't want to break anything. It's their business, that's what they're selling.
Okay. All right, so good. So I think we've got a good discussion here on the architecture of the PBS Pro. So I'll skip through this until the next chapter. see. Installation. So the installation, what it shows here is for the commercial version. So with the open source version, it's much easier. You just use the RPMs and then just install like any normal Linux packages. Whereas the commercial version, it'll ask you a lot of questions. Where do you put your execution directory? Where you put the home directory for PBS and so forth. The other key point between the commercial and the open source is that with the commercial, it package all the third-party libraries that it uses there in the binary, installer binary. Whereas in the open source, it can't package other people's binary into it. So that's why when people are installing the open source version, they need to install their own third-party packages with all the dependencies before the PBS Pro. So I think a few of you here have got experience in installing the open source. Maybe you'd like to share your experience.
Wow, as long as you follow the steps,
Okay.
then you should be safe.
Okay.
Yeah, I have once tried to compile it and install it on my machine, and somehow it crashed the X window. So try to compile it and install it is not, unless you are pretty sure of it.
Or unless it's a VM and then you can simply throw away and rebuild. Yes.
It's not a VM, but I did back up the image of it.
Yes. Okay. And how about Sue? You've tried the open source?
Yes, I have installed from source code.
Okay, good. And you've got some success there?
Yeah, I think so.
Oh, very
Finally.
good. Very good. So what were the challenges?
But the third party dependencies.
Okay.
Yeah. And but still there are a couple of issues. I haven't been able to fix. But I think that the community forum is very helpful.
Yeah, that's good.
Yeah,
That's good.
yeah. I got some tips from.
Interesting thing is, just now you're asking about development teams. One of the guy there, maybe you recognize the name Subhashis Bhattacharya. He's one of the head of the development teams for PBS Professional. Previously, he was a very technical guy. He was like a team lead of the development team, and he was responsible for part of the code as well. So he's a very knowledgeable guy, and I'm actually quite positively surprised that they put him in charge of the forum, or they make him so responsive to the forum. Because a person in his with his capability, he's got a lot of things on his mind, a lot of things in projects and so on, responsibilities and so forth as PBS, but he has been assigned the time to respond to the users' questions. So yeah.
And the one thing is Source, I think, installed on the newer Linux version. That has some functionality.
Oh, yeah, our class is that.
Yeah.
And
I tried to stay with the same hardware 7.1.
Okay. Yeah.
almost a simple too.
No, it isn't that upgraded.
Oh,
It's
in
like
class,
Sync two.
on class.
Yeah.
Oh,
yeah.
okay. We installed the PBS Pro is the 14 version.
Yeah.
Yes, that's fine. That's the open
That's
source
one.
version.
Okay.
Yes,
Yes.
that's correct.
14, yeah, 14.1.
One.
Okay.
Yeah,
Okay.
that's fine.
Yeah.
That's good. Yeah. And you probably may have seen this structure already. That's typically how PBS where it places its files. So there's two main areas. We call it one of them PBS_home. That is where all the logs and the configuration are. So you have the logs on one side, and the other one, the priv, I think it means private. So those are where the configuration sits. Most of them are text-based configuration files. And then at the bottom there, you've got some like miscellaneous kinds of folders. Thing to note is the undelivered is sometimes when a job sort of gets a problem or something, so it may be put there. Spool is when you have, I think, the temporary standard error and standard output files. That's where they live. The data store is very important. It's where the PBS database sits. So,
This is a new thing.
so in fact, for your system administration purposes, if you want to back up PBS, tarball the whole thing and put it somewhere. You have your own backend policy. Maybe it's every day or every week or so. So you decide on that. But the thing to keep safe is this whole directory tree from PBS home downwards.
All right.
Keep it all.
Yes.
You can delete the logs by yourself or
Yes.
something, but other than that, keep it all.
Mm.
As opposed to that, the other one is called PBS exec. So this one are the binaries and some scripts as well. So this is the one where if something goes wrong, you don't care, just reinstall PBS and then copy back your PBS home. So yeah, so the exe, not exe, but the binaries and stuff. Yeah, so the bin and the sbin are where the PBS commands are. So when you install it, if the path is not there, so just point to those paths, the bin or the sbin if you need. So
Because you know the RPM installation, they all go to the common a shared area like /b, /user /bin, /user /bin, not
Okay.
the special.
Okay. Yeah.
What's your experience? I think so. It's not that
I think
there's
I let
no
it
such
install on the default folder.
So this one is for the commercial one. So what we call
the commercial.
PBS exec, when
Right.
they install it, it defaults to the /opt/PBS/defaults.
Right.
And at installation time, the admin can change that to his or her choice of
Yes.
directories, right? Same with the PBS home, which is typically /var /pool /PBS. Yes, that's typical. So the open source one, as you mentioned,
Yes.
I think they put it in the /user is USR or
Yes,
something.
there's split all over that.
Is it all
Yes.
over?
Because it's difficult to build relocatable packages, and it's not encouraged. But it doesn't mean it's difficult to put in /op, because it isn't where you want it. There's no easy way to put it somewhere else. So they just go with the file system standard, which could make life interesting if you try and run more than one version.
So that's why part of the reason why I install it from source code.
Right.
So I can define where I put all the
Okay.
like this PBS.
Okay, that's good option.
It's-
Yeah.
Is this on every node in the cluster, or is this on a specific node?
Okay, good question again. So as we think back to the PBS architecture slide just now, so there's the server, the scheduler, so both one daemon each running on the head node, whereas the moms are running on all compute nodes. Right. So as to where these directory structures are, so the head node will have the complete set of this. So let me just go back to this home. So you have the set of server, scat, and mom, server, scat, mom, and com. That's the head node. Because the head node itself can also run compute if you configure to do so. So that's why it's got a mom there. On the compute nodes itself, the important ones would be the mom. I think they may leave out the server and schedule brief, I'm not sure, but even if they didn't leave out, it wouldn't be functional.
Right.
So all you need to consider is the mom priv and the mom logs on the compute nodes itself. Yeah. So yes, every node needs PBS to be installed. And there's do you know about the command to quickly install?
No.
Because it's called PDSH. So if you look it up through the installation guide, PDSH, so it's parallel distributed shell.
Oh, but this is a Unix command.
Could be, yeah, could be.
Yeah.
Could be.
I tried it, but we don't have this like on our system.
Probably something installed.
No, probably here.
Yeah.
Or you might find it
It
in
might be
install
coming from
directories.
PBS.
Not from this. I think this is
It could be
command.
Unix Linux command, right?
Linux.
Yeah. So PBS uses it, yeah.
But
Oh,
it will
yes.
not be able to know your node name.
Yeah. So you have to tell it, there's more to it, so you have to tell the options.
Yes.
So in the manual, it will tell you, so by running one line, you can install thousands of nodes
Yes.
Yeah.
at one time.
Yeah. But it will install on the compute node just the PBS one things, and the head node is PBS and PBS exec.
Yeah, that's right.
And the things. Yeah.
So when you have a parallel job, for example, if something crashed, it's a multi-noded job. So the logs you may want to look for is the mom logs on the compute node itself, not on the server node.
Right.
Yeah. So you may need to know which node that particular job has run on, and then as admin you SSH into those nodes, and figure out the logs. Okay, so exit and home. All right, so we've done the initial part about our previous architecture, and let me just go to the other part, which is go back to the top. So I'm going to go to the limiting, the custom resources, built-in resources, and then limiting resources. Okay, let's see if control point works now. Okay, we're going to jump straight to, in the interest of time, let's jump to the custom resource, which is chapter 12, and then the limiting resource as well, chapter 14, 6269, 302. 269. Custom resource, okay. So tell me what you know about the PBS resources so far.
Let me see, PBS
So,
resource.
yeah, so resource are what we mean when we say the NCPUs, the MEM,
Right.
what else? The host,
Yeah.
the wall time, and
Yes,
such.
yes.
So let's talk about the built-in resources first. You see that there's one class of resources which is like NCPUs and MEM, and another class of resource which is like wall time. Can you tell me the difference between these two classes?
Yeah, wall time is how long you want your job to run for. CPUs is how many cores CPUs you want to reserve.
Yes.
Memory is how much RAM.
Yes, that's right.
Yeah.
But if I put the NCPUs and the memory in one class of resource, and then I put wall time into another class of resource, can you see the difference? Why I would say that there are two separate classes of resource. What's the difference between NCPUs and memory
There's an upper limit
concept?
to those.
Sorry?
It's an upper limit to those. Whereas the time, you can specify any time between now and eternity.
Sort of. Yes, I think you're getting to what I wanted to draw out, which is the NCPUs and the memory are host level resource. So you have to think of it in terms of every node. Okay, like your cluster maybe have got how many nodes does Artemis have?
130 something.
130. Okay, let's say 100, 150 or something.
Yeah.
So sometimes the cluster may set up such that different nodes has got different number of CPUs. Some may have graphics card. Some may have more memory than others, right?
Mm-hmm.
So when you submit a job and you specify the NCPUs and memory, you have to think about like that you are using nodes, and those nodes can have different resources. Sometimes if you ask for too much resources, maybe not all nodes can have them, or maybe only some nodes have them. So think about it that way. And then wall time, think about it as a overall kind of resource. So we call it a job-wide resource, because wall time doesn't have the concept or notion of any single node job. So wall time applies to the entire job.
Wall time is elapsed time, the wall
Correct.
time.
Of the clock, correct.
The clock.
So when the job runs to it,
Starts,
finishes,
you finish.
so that's the
That's
wall
the
time.
wall
So that covers it's the entire job thing. So that's why we call it job-wide
So
resource.
it's typically used for deadline rather than
Sorry?
it's typically used for a deadline if
Yes.
you need a job run.
Yes, correct.
Yeah.
Exactly.
So otherwise don't really care how long the time is elapsed.
Exactly. And what's stopping people from putting a very, very long time? What's holding them back?
They never run it.
Yeah, good. So yes, so the schedule itself has got it depends on the actual logic of the schedule. So it has got benefits, and it sort of has an internal mechanism to stop people from being greedy, so that they don't request too much resources. Okay, so of course, people running parallel jobs, big simulations, calculating the galaxy collisions or something, they want as many nodes as they want, as much memory, as much wall time. But then if they ask for so much resources, their jobs will be placed behind the queue. So smaller jobs will run first. So there's a balance that they have to consider.
Okay. Is that resource allocation policy, is that
No,
definable or is that built in?
Yeah, yeah. So there's a lot of competing policies that sort of determines what position in the queue. In terms of, there's a lot of policy. So things like backfill, fair share, strict ordering. Yeah, to name a few. I think chapter 4.8 of the admin guide is like, I think 50 or 100 pages on scheduling policies itself. And some of them are competing. Yeah, and just have to be careful which one you turn on. Yeah. Okay. So those are the built-in resources that I've mentioned. And then on top of that, there are custom resources. So custom resources are things that you can define yourself. So just a very simple example. The PBS by itself doesn't have the resources to count for GPUs. But instead of that, we let the sysadmins define their own custom resource called NGPUs. So something like NCPUs, but this is called NGPUs, where the user define themselves in the configuration files, right? So it works similar to NCPU. So the job, when the user requests it, they will specify NGPUs equals 1 or 2 or something. And then PBS will find the nodes which has already available X number of NGPUs and it will match for the nodes.
And the question is, just say if you define NGPU equal to 1,
Yeah,
if one user using NGPU,
yeah.
does it make that node unavailable to anyone else?
If
Like even the NCPU is available.
no, it wouldn't do that. It wouldn't do that unless you've got the sharing turned on to exclusive hosts.
Okay.
Yeah.
So that even if the user just specify NGPU, he needs to specify NCPU too.
Correct. That's right.
I think that's only one, wouldn't it?
Yeah.
Yep.
Yeah. So otherwise, if you don't specify NGPUs, it'll give you any node. But if you specify NGPUs, it will look for nodes which have GPUs. Because people don't usually install GPU cards on every single node.
That means that that node is still available for other resources like NCPU.
Yeah. So if it's not set as exclusive, yeah.
And the custom resources, are they arbitrary or do they have to be within a given set, like NGPU? So if you put something really strange into some of your nodes,
Right.
I can't think of anything, say a discrete Fourier transform card or something like that.
Yeah.
Can you specify that?
It's totally abstract.
Right.
So the NGPUs is just the name we give it. So you can say MGPUs or something if you like. So it's totally definable. So name is definable, and more importantly, the data type is definable. So it can either be a string, a long integer. I think those are the two main ones. I think it could be a mem as well. So PBS has got the memory data type. Yeah. So it's more convenient to deal with memory internally in subsource.
So all the commands can handle arbitrary keys that refer to resources.
Correct. So in that sense, so you define the arbitrary resource and then you set the resources on each node or a server. So again, it could be a host level custom resource, in which case you set it for each node, or it could be a system-wide, we call server level resources for server. So another typical example is a real example is a license count. So for example, ANSYS has got its own license, and then we have no idea of the license counting of ANSYS, but you can set a custom resource called ANSYS license or something, or N number of license or whatever, and then you can set a dynamic process that actually looks into that resource dynamically.
Does it for the license server?
Yes, that's right. So the ANSYS has got their own license server. You write a Perl script to poll the ANSYS license server, but the output of the Perl script has to be a single integer representing license count.
Right.
And then in your scheduling policy, some custom resource policy, you point to it the name of that script, where you put the script. Okay, and then so that's called the dynamic custom resource. So if you look up that word dynamic custom resource, you see some examples of how to set it up.
Yeah, beautiful.
Yeah.
That's really good.
It's very quite arbitrary.
It's very arbitrary. It's
Yeah.
totally arbitrary.
Okay, things even
It's
like
a
that.
yeah.
That's cool. So you can point it to license servers and then with that script configure it to work out how many license servers are available.
Yes,
Yeah,
that's right.
From LM stat, it's flex.
Yeah.
Yep.
Yeah, so people have done that with Flex. And then you set up such that your users need to request for that custom resource in their job, so that it sees dynamically whether there's enough licenses.
So I go ANSYS licenses equal 100.
Yeah, that's correct.
All their job is equal 100.
Yeah, yep, that's very good.
Right.
Cool. Okay. So I think we got the idea for a custom resource. Oh, you can have the custom resource at queue level too. So for each queue, you can have some resource. Just a typical example. By default, PBS configures one queue and all to all nodes. It's called default work queue. And if you want to, you can have other queues configuring to a specific number of nodes. But the basic level of configuration is one node belongs to one queue only. Okay, so you got a certain queue targeting X number of nodes, another queue targeting Y number of nodes. They are separate sets. Okay. Sometimes you want particular nodes to belong to multiple queues. Okay, so that one we have a second way of defining the queues, and that actually makes use of custom resource.
Yeah.
So it's a matter of defining a mix and match of which nodes going to which queues.
So all these will be put in a configuration file,
Exactly.
single configuration file.
Not single configuration file. It is split out. It's by the use of custom resource, and then it's defined on the node level too.
Yes.
So on the node level resource, you can define. Say the custom resource is called queue list, okay, and then you can define it on the node 1. The queue list equals queue chemistry, queue maths, and then on the second node, you define that custom resource queue list equals queue statistics, queue veterinary science or something. Okay, and then so you have to define the custom resource already, the one called queue list. So there's a recipe for that in the manual. Yeah, I can show you later. It's a recipe.
Okay, good.
Yeah.
So does it have to be the custom resources has to be defined with a Perl script? Can it be another scripting language?
No, the Perl script itself is the script that you write to poll the license server of that particular case that you want. The custom resource itself is text based of how you configure it, so it's nothing to do with Perl script. It's just on the let me see. Well, from PBS 12 and below, there is a configuration file called resource dev where you define it. With PBS 13 onwards, it's even easier. Use the QMGR command. So you say like QMGR create resource name equals something, and then you give it the thing. So I'll give you the details about that later. So be sure to remind me.
Yeah, I will.
So the Perl script really only just has to be executable. It doesn't have to be a Perl script.
With the dynamic host reason, I think it has to be Perl script for some reason.
So it's
for some
basically another
legacy reason.
That,
Maybe. Yeah. So that's for the use case where you have to read something else. Yeah.
Right.
Okay.
Yeah.
All right.
Later.
Yeah. Let's move on to the last chapter that will be interesting or useful. Okay, limiting resources. So this chapter is about limiting how many jobs, for example, your users can submit or run, or you can place limit at a group level, and you can place limit at a project level. So can I ask whether there's a need for this so far that you have encountered?
Absolutely, yes, we use it already.
Okay, that's good.
I can't imagine any non-single, any system that's not insignificant would need this sort of thing, because there's always people that use more of this.
Yes, it's
always.
Yes, that's right. Okay. So, Stephen, would you like to comment on how the Artemis is set up using the limiting resources?
I don't know how we've set it up.
I mean the policies.
The policy, where you have a number of queues, and those queues have various limits. So there's like wall time limits. There's different queues. Some have longer wall times, some have shorter wall times.
Right.
Some queues allow you to run, like we have queues that allow you to run jobs at 288 cores.
Okay.
Other queues that only allow you to use 96 cores. And so another queue allows you to use 24. So things like that, so we don't have like one or two people just blasting the whole system of their jobs and locking everyone else out.
Okay.
And we've customized it for different size jobs. So different resource pools for different size jobs. I think using this resource and everything.
Yeah. Okay.
I haven't done the customization myself, but I know we have it in place. And it's
No, that's good. That's good feedback.
Yeah.
Okay. So I think you got the gist of how this is used and what it's for. Okay. So I think with that, I think we've gone a bit over time of the recording. So I'll wrap up the recording now, and then we can continue our discussions ourselves. So all right. Thanks everyone. Thanks for the session.
Thank you.
Mm-hmm.